Today we're going to chapter 15, talk about mechanical waves. The wave always produced by vibration. So if you see a wave, always has a vibration. Along with a certain direction. So the wave has a sine or cosine shape. As a periodical wave. The smallest repeatable unit, along with the propagation direction, it has a distance called a wavelength. Normally use lambda. Greek letter num is called lambda. That's a meter because it's a distance. The time for the wave to have one complete vibration or traveling one wavelength distance is called a period. Normally it's letter T in second. So basically that's also the time for that period of time. And then the wave also go with kind of velocity v in meter per second. We also introduce the third physical quantity called a frequency, f in hertz. So the frequency basically is 1 over t. That given the number of vibrations in 1 second. The number of vibrations in 1 second. It has unit hertz. Now the relationships. The relationship between those four items could be expressed by the wave's velocity equal to the wavelength over period, or because 1 over t equal to f, so the wave speed can also write by the wavelength times frequency. So it depends on which one you want to find. If you know any two, you're able to find the other two. Remember the four physical quantities: wavelength, period, wave velocity, and frequency. So I'm going to rewrite that relationship over here. The frequency is 1 over t. So all those three equations actually give all the equations you should know for mechanical waves. So we have two types of waves. Two types of mechanical waves. One is called transverse wave. While the wave goes this direction, while the vibration goes perpendicular to the wave direction. So the wave traveling this direction, while the vibration goes perpendicular to the traveling direction. So that's what it is. And the second type is called longitudinal wave. The wave goes this direction, and the vibration goes the same direction. So that's called a longitudinal wave. For example, transverse wave, the light is transverse wave. Longitudinal wave, sound, is non-digital wave. The fourth point for chapter 15 is a wave speed on a string. So this is mostly related to music instruments with strings. For example, a violin or cello normally has a string with a certain mass, m in kilogram, and it also has a certain length, L in meter. That's the length. Also, you have something maybe screw over here to adjust the tension force over the string. So the tension force, I'm going to use letter F over here because it's the force in Newton. So the wave speed actually is determined by the three factors over here. The first, you need to find out mass per unit length for that string. It's a mu equal to the mass over the length. So it has unit kilogram per meter. And then second, you are able to find out the wave speed by the square root of the tension force over the mass per unit length, mu. Of course, that is meter per second. Now, we also learned a little bit from chapter 16. So chapter 16 talk about the light or electromagnetic wave. So the light is actually an electromagnetic wave. First, you need to know what are vibrating in electromagnetic wave. Suppose the wave goes this direction, and if you look at X, Y, Z three directions, you're going to find, okay, so the electric field goes vibrating like this. And the magnetic field goes vibrating this direction. So, and this is the propagation direction, the wave velocity. The three, electric field, magnetic field, and the wave direction actually perpendicular to each other. So in that case, we see the light is actually transverse wave. The second, the light speed in vacuum. So the light speed in vacuum is actually a constant, c equal to 3 times 10 to 8 meter per second. That's normally used as a number for any wavelength. So apply the equations for mechanical wave. You have the speed of light equal to the wavelength times frequency. That's mostly frequently used equation for the light. Now we also need to know the electromagnetic spectrum. So if you look at the electromagnetic spectrum in the full range, so you're going to have from the highest frequency to lowest frequency, or from the shortest wavelengths to longer wavelengths. So if this is the wavelengths, you're going to have first have gamma ray. That's the highest frequency or the shortest wavelengths. And then you have X-ray. And then you have ultraviolet. That's UV light. And then you have visible light. And then you have infrared. And then you have microwave. And then you have radio wave. So you have 1, 2, 3, 4, 5, 6, 7 types of light. So you should know this. From gamma ray. Okay, sorry, gamma ray is actually represented by Greek letter gamma. This is the gamma. So gamma ray, X-ray, UV light, visible light, infrared, microwave, radio wave, 7 types.